Good evening. So I'll go straight. This is linear programming, and linear programming questions are usually solved by two most prominent methods, which are graphic method and simplex method. So we are going to feature mostly graphical method to solve linear programming problems. Okay, so to do this, you need to identify several things, majorly 3 or 2. So the first thing is an objective function. You need to find an objective function. So what is an objective function? So these are functions that are supposed to be optimized, that is to maximize or minimize, so that you express it as a linear function or as a function. So that is the first one. The second one is these are constraints. So you need to have constraints and you need to have an objective function. Okay, so you need to have an objective function, very important for you to have that objective function. The other thing you need to have are the constraints. So how do you know which is which? Because the objective functions and the constraint seem to look alike, but a major difference between the two is that, looking at this one is the objective function. Okay, the one that says maximize, this is the objective function, subject to, so these are constraints. It's supposed to be less than or equal to. Also for this one should be less than or equal to. There's a small slight error there. So these ones are constraints. This is the objective function. That means you should solve this subject to these constraints. So normally in exam questions, you either have such kind of a question, either you have this one that looks like this, or you have a question like the one above, whereby you need to actually get the objective function and the constraints. You need to actually take time and derive them from this information that you're given right here. So let's go straight to that. So you are told a manufacturer has two products, P1 and P2, both of which are produced in 2 steps by a machine. So M1 and M2. So the process time per 100 for the products on the machine are, so you have M1, you have M2, which are machines, and then P1, P2 are products. Okay, so you can see that P1 contributes 10, so 10 per 100 units, and the contribution for P2 is 5. So we have constraints here. Okay, so what are constraints? So a constraint is something that is limiting you to do something. So we would want to produce all the products P1 and P2 in the world so that we can sell, but we are constrained by different things. One, we are constrained by time. So we are limited by time. That means we have 24 hours, but we can't work a whole 24 hours. Okay, we can't work 7 days a week. That means we are constrained in time. Okay, we also constrained in the times of machine 1 can work a certain period of time, machine 2 can work a certain period of time, so it can't work 24/7. So that's the constraint of time. So given these constraints, and also you also have to remember that product 1, there's a certain mix that has to happen in M1, which is machine 1, and machine 2 to produce something. Okay, so we are constrained in terms of the product and also in terms of the available hours. Okay, so we are saying the manufacturer is in a market upswing and can sell as much as he can produce of both products. Formulate the mathematical model and determine the optimal product mix. So you want to determine the optimal product mix. So how much should this guy or manufacturer produce? How many quantities of P1 and how many quantities of P2 should this guy produce given or subject to the constraints so that he has an optimal product mix. So that's what you are looking at. So you're given the constraints of time and you're told this is the objective function. That means this is the profit function. That means we want to maximize on the profit. So for us to maximize on the profit, given the constraints, how many products of P1 should we produce and how many products of P2 should we produce? So this looks a lot like calculus or maximizing in calculus, but it's a bit different because there are a number of assumptions that are given in linear programming questions. So looking at this, the first thing you look at is, okay, machine 1. The constraints are 100 hours. That means machine 1 can only work for 100 hours, machine 2 for 80 hours. Okay, so here we are going to assume one is X and the other one is Y. Okay, so how do we do that? We are going to have 4X plus 5Y, okay, must be less than or equal to 100. So this is what we've just taken here. That's the first constraint. Okay, so we are assuming X is P1 and Y is P2. Of course, we can work with P1 and P2. You'd not have a problem with that. But I'm just using X and Y because that's what we are normally used. So I'm just using X and Y, but we can use P1 and P2. So X is P1, Y is P2. Then the next thing is you go to the next one here. You'll have 5X plus 2Y. Remember, you're forming an equation is less than or equal to 80. Okay, so you have formed two constraints or two constraints or limitations there. So what is the interpretation of this? If you mix 4 P1s plus a certain quantity of P1, so P1 is a quantity, okay, it's a product, yes, but it's a quantity of P1. So you're saying if you do 4 of P1 plus 5 of P2 has to be less than 100 hours. The same applies to the other one. 5x plus 2 of y must be less than 80. Okay, so those are our first two constraints. Then now, because this is contribution, remember this is contribution per 100 units. So this is where we are going to form the objective function from. Again, I said the objective function is like a profit function. You want to maximize on the profit. So now the contribution, you are going to have our z function. We are going to have z, which is the profit, is equals to 10x, remember x is P1, plus 5y. So now you have your objective function and you have your constraints. Okay, you have your objective function and you have your constraint line there. Then something else that you need, of course, to put is you cannot have a negative P1 and you cannot also not have a negative P2. That also means you cannot have a negative x and negative y. That means we need to put a non-negativity condition. So what is a non-negativity condition? Just a condition saying that x and y must be greater or equal to 0. That means you cannot have negative product x, you cannot have a negative product y. So now these are our constraints here. Then this is our objective function. So we are going to see where we will apply this objective function. So we'll get values of x and values of y that are going to be optimal to get the best profit or to maximize our profit. So now when you have these constraints, what do you do next? When you have now this constraint, the next thing that you need to do is now you need to form a graph. Because these are linear equations, you need to form a graph because remember we are solving in the graphical method. We're using graphs to solve. So what do you do next? So I'm just going to go down here and just form a graph. I'll form a graph right here. So I want to form about 2 lines. So the first line I'm looking at is the first constraint right here. So the first constraint is 4x plus 5y is less than or equal to 100. So I want you to know that this is not a line, this is a region, but we want to make, or we want to draw a line. So what do? We replace this less than or equal to with an equal to sign. Just replace it with an equal to sign like that. So now you form a line, a straight line, which is 4x plus 5y is equals to 100. The next, of course, is going to be 5x plus 2y. Replace that less than or equal to with equal to 80. The other line that we are going to make is x is equals to 0 and y is equals to 0. So those are the ones we are going to make. So of course we are deriving x is equals to 0, it's on this place, and y is equals to 0 here. So the next thing is now we want to form the line 4x plus 5y is equals to 100. So what do? Now if you want to draw any straight line, you just need to identify 2 points. Okay, any straight line, just 2 points, this and this, and you can draw a straight line out of that. So that's what we just need to do with our first equation here. Okay, so what we'll do is you're going to have 4x plus 5y is equals to 100. So we are going to let our first make x be a 0. Okay, so we assume our first point x is 0. So why do we put 0? Because 0 will make our work very easy when we are dealing with this equation. You'll see just how to do that just now. So if we put for x to be 0, so let's assume our first point x is a 0. So we'll have 4 times 0 plus 5y is equals to 100. So of course that is a 0 now. 5y is equals to 100. So divide by 5, you'll get y is equals to 20. So when x is 0, y is 20. So that's our first point on that line. Now let me just remove this, and now let's make y be a 0. Okay, we first made x to be a 0, and now we're making y to be a 0. So we are going now to have 4x plus 5 times 0 is equals to 100. So now in the next point we are assuming that our y, so we don't have x, so our y is 0. So now we are looking for x at this point. So now we are going to have 4x is equals to 100. Divide by 4, divide by 4. So this is 20. So when y is 0, our x is 20. So we'll have 20 here. No, sorry, 25. This should be 25, not 20. This is 25. So this should be 25. So now we have our first line. Our first line is of points 0, 20 and 25, 0. So now let's go to our next equation. Our next equation is our next equation is 5x plus 2y is equals to 80. So make x to be 0 so that you'll have 5 times 0 plus 2y is equals to 80. So 2y is equals to 80, divide by 2, divide by 2. So you're going to get this is 40. So when x is 0, now we are in the second. So when x is 0, y is 40. Now the next point on that line is going to be, now let's make y to be a 0. So when y is a 0, you'll have 5x plus 2 times 0 is equals to 80. So 5x is equals to 80. Divide by 5, divide by 5. I believe this is 16. So this will be 16 there. So when y is 0, x is 16. So finally we have now our 4 points there, our two points. So of course the other one is x is equals to 0 and y is equals to 0. You can easily draw that. So that should not be a problem. Perfect. Now we have that drawn. So I'll just label our points here. So I'll have, let me just have 10, 20, 30, and 40. 10, 20, 30, and 40. So this is 10, 20, 30, 40. 10, 20, 30, and 40. So our first line is 0, 20. So 0 for x and 20 for y. So that's our first point. The other one is 25, 0. So 25, 0 should be here. So our first straight line, let me try draw, looks like that. So remember, the region we are interested in is the region less than. Don't forget this less than here. So we are interested in less than, this one. Very important. So we shade the region that we don't want, because we have drawn the line 4x plus 5y is equals to 100. That is on the line now. That is the line. But we want a region less than. So less than is of course this side. This is the less than side. So we shade the side that we are not interested in, which is this side. So I'll just shade it like this. Now I go to our next line, which is 5x plus 2y. So for our first one there, we have 0, 40. So 0, 40 is here. And the other one is 16, 0. So 16, 0, I'll presume it's somewhere here. So again, I'll draw a straight line like that. So again, less than. So we need this side, we don't want this side. So I'll shade the side that we are not interested in, like that, so that I maintain the line that we are interested, the side that we're interested in. Then for the line, we have drawn our two lines now. So for the line x, x is equals to 0. So which is the line x is equals to 0? The line x is equals to 0 is our y-axis. So I'm going to draw that line like this. And because we are saying greater than, remember here we are using greater than. So we are using greater than here. So this is the one that we are looking at. So the region greater or equal to. So the region that is greater than is actually this side. So we shade the one that we don't want, which is this side, like this. So, and then the line y is equals to 0 is the x-axis. So again, we draw that, and then we are looking at the region greater than. So we shade the one that is less than, this one that we are not interested in. So finally, you find that the place that you are interested in is actually this this space here. Okay, up to this point, going this way. So this is the space that we're actually interested in. So now this is to say that any point on that white part will actually satisfy our conditions. Okay, so it will satisfy. So now if you want to get the point that will maximize our objective function, how do we get that? We get it in the vertices. What are vertices? If you have a triangle like this, this is a vertex, this is a vertex, this is a vertex. Okay, so we get the vertices. Those are the ones that we're interested in. So the vertices, one of the vertices here is the point that we need. So I said any point inside this white space can be used in our objective function, but you want the point that maximizes. Okay, you want the point that maximizes. So what do? You get the vertices. So remember, our white space looks something like this. This is how our white space looks like this, then like that. So we are looking for this point. We are looking for this point, this point, this point, and this point. That's what we are looking at. So of course we know for this point this is 0, 0. You already know that. For this other one, this is 16, 0. We had already calculated it. For this other one is 20, 0. We had already gotten that. So the point that we don't have is actually this point here. So how do we get that point? That point we also now do another calculation, because this is the point where the two lines cross. So we have line 4x plus 5y is equals to 100, 5x plus 2y is equals to 80. So those two lines cross at that particular point. So how do we find that point? We find it by solving the two equations simultaneously. So there are different ways of solving equations simultaneously. So the first one is substitution. You can use elimination, and whichever method you find that you can use or you're comfortable with. Remember, we are just looking for this particular point here. Okay, so the next thing you do is, let's solve it using elimination. Probably elimination will do. So if I multiply with 5 on this side and 2 on, let's eliminate y. So that now I multiply this side with 2 and this side with 5. So that I'm going now to have 8x plus 10y is equals to 200. This side I also do 25x plus 10y is equals to 400. Okay, so now let's eliminate. Of course it's a minus, so if it's a minus, we are going to have 8 minus 25y. Of course this should be, I think it should be 17, negative 17. So negative 17x is equals to negative 200. Remember, y has been eliminated, so of course divide both sides by 17, divide by negative 17. Okay, so that you find what you're going to get for y. Okay, so doing a quick calculation there, 200 divided by 17, you actually get x is equals to 11.777. So now, having gotten x, you can get y by substituting x on any of those equations there. So if we put it on the first equation, we are going to have 4 times 11.77 plus 5y is equals to 100. Remember, we are looking for y. So the next one is going to be 4 times 11.77, which is 47.08. 47.08 plus 5y is equals to 100. Take this to the other side, so that you have 5y is equals to 100 minus 47.08. You're going to get 52.92. So ideally, you're going to get y is equals to 52.92 divided by 5, which is 10.58. So y is 10.58. So now on this part, now we've gotten x is 11.77 and y is, can grab this, and y is 10.58. Okay, now having gotten that, we can now substitute it on our objective function to see which one has or maximizes our profit. So that's the last thing that we are supposed to do. We have our 4 points, our 4 vertices. Now our issue is just now to substitute on our objective function. Remember, our objective function is z. Let me just use a totally different color. So z is equals to 10x plus 5y. That's our objective function. Okay, this is our objective function, right? So now, having done this, I'm just going to do z 10 multiplied by x. So if we substitute on at this point here, this one here, you'll get 0 0. So times 0 plus 5 times 0, of course you're going to get the answer as 0. So here the answer is 0. Now when we substitute it on the other point will be 16x and 0y. You'll get 160. So this will be 160, this point here. Now you go to this other point, you substitute with 20 for y. No, this was supposed to be 0.20, not the other way around. This is the point 0.20. Yes. So you are going to have now 0 here and 20 here. So that finally you're going to have 100, just 100. This is 100. So for this point here, you're going to get 100. Now for this other point, the last point, the one that we calculated, you're going to have, let's remove this and this. Sorry. So if you remove this, you're going to have 11.77, and this other one is going to be, this other one will be 10.58. So when you do this calculation, which is, this is going to be 117.7 plus 5 times 10.58, you get 52.9. So eventually you'll have 117.7 plus 52.9, which is 170.6. So this is 170.6. So eventually you get that this is the point that will maximize or will optimize our objective function. So this is the point where our objective function is optimized. So thank you.